The electricity in your home does something strange. It does not flow steadily one way. It surges forward and backward, 50 times every second, reversing direction constantly. This is alternating current, and it powers the entire planet. Why use something so restless instead of a steady flow? And how do we even measure a current that is always changing? This unit builds in four moves. The difference between alternating and direct current, the clever idea of root mean square that tames a changing current into a single useful number, how power works in an AC circuit, and rectification, the trick that turns a C back into DC. Let's start with the two kinds of current. Direct current flows steadily in one direction, like the current from a battery, a flat, unchanging line. Alternating current constantly changes direction, tracing a smooth sine wave that rises, falls, reverses, and repeats. A battery gives DC, the mains gives a C. The mains in many countries alternates 50 times a second, a frequency of 50 Hz. A C is described by an equation. The current at any instant is the peak current times the sine of omega t, where omega is the angular frequency. The peak value is the maximum the current ever reaches. But here is the problem. Since the current is constantly changing and even averages to zero over a cycle, what single number should we use to describe its strength? The ordinary average of a C is useless because it is zero. The positive and negative halves cancel out exactly. So we use a clever measure, the root mean square, or RMS. It is the steady DC value that would deliver the same average power. In effect, it asks, what constant current would heat a resistor just as much as this alternating one? For a sine wave, there is a beautiful exact result. The RMS value is the peak value divided by the square root of 2, about 0.7 of the peak. The same factor links peak and RMS voltage. So when the mains is quoted as 230 volts, that is the RMS, the actual peak voltage is markedly higher, around 325 volts. This is exactly why RMS matters, power. The average power delivered by a C is found using the RMS values, not the peak ones. Average power equals RMS voltage times RMS current. If you mistakenly used the peak values, you would overestimate the power by a factor of 2, which is the single most common AC mistake. There is a neat consequence worth remembering. Because each RMS value is the peak over root 2, multiplying two of them together brings in a factor of 1/2. So the average power of an AC supply turns out to be exactly half its peak power. The current spends as much time small as large, and it averages out to precisely half. Many devices, like anything with a chip inside, need steady DC, not alternating mains. Rectification converts a C into DC using diodes, components that let current flow one way only. A single diode gives half-wave rectification. It simply blocks the negative halves, leaving a bumpy one-directional output with gaps where the missing halves were. Better is full-wave rectification, using 4 diodes in a bridge. Instead of blocking the negative halves, it flips them up, so all the humps point the same way. The output is still bumpy, but a capacitor in parallel then smooths it, charging on the peaks and discharging through the dips to produce something close to steady DC. Here is the whole unit as one poster. Direct current is steady. Alternating current is a sine wave that reverses, described by I equals peak current times sine omega t. Because its ordinary average is 0, we use the root mean square, the equivalent steady value, equal to the peak divided by the square root of 2. Power always uses RMS values. Average power is RMS voltage times RMS current, which works out to half the peak power. And rectification turns a C into DC, one diode for half wave, a photodiode bridge for full wave, then a capacitor to smooth the output, and the boundary fence so you do not over-revise. The detailed physics of capacitors charging and discharging, the inductors and reactance of AC circuits, and the workings of the transformer are all A2 topics. Here it is the essentials: a C versus DC, peak and RMS, a C power, and turning a C back into DC.